All right, this is our last lecture day of chapter 19 and also the last one for the semester. So this is great. We're really close to the end. Let's power through this one and then we'll be done. I only have two brief topics to cover for today: chain reactions and explosions. Let us begin with chain reactions, okay? So first I'll describe it verbally, and then we'll actually see what chain reactions look like. They occur when the products of the reaction promote other reactions of the same type nearby. And that will result in a positive feedback loop where the reaction will amplify, sometimes very, very quickly, and that will cause a snowball effect. And probably the most famous chain reaction occurs within atomic bombs. And we're going to be hearing a presentation about atomic bombs this week, but I'm just going to reiterate this reaction. If we have uranium-235, of course it's element number 92, then it's possible for a neutron, if it's moving the proper velocity, to encounter that uranium nucleus, and then a reaction will occur where it will form barium and krypton. And barium has mass 141, element number 56, and krypton has mass 92 and element number 36. But it will also form 3 new neutrons. So it takes 1 neutron and then releases 3 of them. So that's a net increase in 2 neutrons. And each of those neutrons can then move on and find their own uranium-235 nuclei to react with. And so the only way to stop this reaction was if you ran out of uranium-235. And so this is the mechanism by which one of the atomic bombs worked. So that's an example of a nuclear chain reaction. But we also have chemical chain reactions. That was actually the first type observed. One example of this is where we have bromine reacting with hydrogen gas. It's possible for this to form hydrobromic acid. And this is the mechanism. We can have Br2 spontaneously split up into 2 Br radicals. And this step is called the initiation of the reaction. Then one of those bromine radicals can interact with one of the hydrogen molecules and form HBr. And that will result in a hydrogen atom radical. Then that radical can go on to react with another bromine molecule and form another HBr and yet another bromine radical. So these 2 steps of the reaction are called propagation. So how does the reaction end? Well, one way that the reaction can end is for 2 bromine radicals to find each other, forming just Br2. And this is called termination. So as we can see, we've got different types of chain reactions. There can be, more famously, the nuclear chain reactions, but it's also possible for chain reactions to occur in chemical situations. So the last thing I want to talk about are explosions. And as you may guess, explosions can just be very rapid exothermic reactions that release a lot of heat. And then this heat can therefore promote a greater quantity of the reaction to occur, and then the reaction just runs away and it goes very fast. And especially if it involves gases, large numbers of gases within the products, then a massive expansion will occur and you get a rapid increase of pressure or volume along with a massive increase in heat. That's one type of explosion. But here is a very interesting fact, that if you have explosions from radicals like if we had a reaction similar to the one we saw on the last slide where radicals were involved, then you can get some very strange behaviors. Now, along this axis of this figure, this is actually pressure, okay? So within certain ranges of pressure, like from here to here and from here to here, the substance is stable, or the reaction rate is measured. But within a certain critical region of pressure, an explosion can occur. And an example of this is relevant to welding. I don't know how many of you have ever taken a metal shop class, or like maybe in high school, or have ever done any sort of acetylene welding. Back when I was in middle school, they still allowed you to do that. I suspect that that's unfortunately been taken out of most schools for safety concerns, but it's really a shame. Anyway, when you do acetylene welding, then the reaction requires oxygen gas. And oxygen gas can be stored at arbitrary pressures. There's no danger of storing it at high pressures as long as the tank is able to withstand it. But acetylene is a different story. This is the molecule of acetylene. And if you store it at certain pressures, it will spontaneously combust. So for that reason, they have to store acetylene at either lower pressures, or what they'll also often do is they'll put an agent mixed in with the acetylene, kind of this sort of spongy, kind of amorphous substance that is very porous, and that helps prevent the acetylene from reaching that point where it will spontaneously explode in the tank. Well, that concludes our videos for the day and for the semester. Congratulations on making it this far. It was my pleasure to teach you all. I am really looking forward to the presentation about the Manhattan Project. I'm really excited about that. And I will be reaching out with more information concerning the final and anything else that needs to be done before you receive your grades after finals week. So with that, thank you very much, and thanks for bearing with me during this difficult time. And I wish you all the best with your homework and with your final, with your other classes, and beyond. Take care, everyone, and God bless.